Good afternoon, class. Today we'll be discussing grouped data. When your distribution is very large, it is difficult for you to do some things like drawing bar charts, calculating your averages, and so on. Not that they are not possible. For example, look at this distribution here. If you want to draw bar chart for this, you have 20 rectangular bars, and you know it's difficult for you to work with that. Also, to get the mean for this is somehow difficult, not that it's not possible. Therefore, we came up with what we have as group data that will make you to work in an easier form. But before you start grouping, there are some statistical parameters that you need to know. The first one, we call it the class intervals. Your class intervals are groups into which the data is classified, and each group must contain equal units of information. For example, for you to achieve that, you have to make sure in the distribution you know the smallest number and know the highest number. In this distribution here, the smallest number is 40 and the highest is 59. So I want to generate 4 classes. Therefore, see my classes, the groups. I'm using 40 to 44, 45 to 49, 50 to 54, 55 to 59. When you check each group, you discover they contain equal unit 4, 4, 4, 4, 40 to 44, 4, 45 to 49, 4, 50 to 54, 4, 55 to 59, 4. They have to be equal. If I want to continue with this same, then I will have the next one to be 60 to 64, the next one 65 to 69. All this you have here, we call them our class intervals. They are the groups for the classification, and they are containing each of them is containing equal units of your data. Now, another important thing you need to know, we call these class limits. Class limits are the end numbers of each class interval. For example, when you take this class interval, 40 and 44 are the class limits. The 40, which is smaller, is called the lower class limit, while the 44, which is bigger, is called the upper class limit. Similarly, when you take this class 45 to 49, 45 is the lower class limit, 49 is the upper class limit, and so on. Another thing you need to know is what we call the class marks. The class marks are the mid values of your class intervals. Mid values of your class intervals. For example, if we consider the same class intervals given before, that above, if I want the mid value here, you add the lower class limit to the upper class limit and divide by 2. Like in this case, 40 plus 44 over 2, which will give you 84 over 2, and that is 42. Or, look at me here. When I say 40 to 44, I mean 40, 41, 42, 43, 44. The mid value here is this one, 40, 41, 42. That is another method. Similarly, when we say 45 to 49, you add this to this and divide by 2, which will give 47. Or you just come 45, 46, see the mid one, 47. The same thing, 50, 51, 52. Because I'm counting from 50 to 54, which is this. So I have 5. Or just say 50 plus 54 over 2, which will give 52. 55 plus 59 over 2. Add first before you divide. You have 57. All these are called the class marks. They are the center values for the class intervals. When we talk of class boundaries, we use class boundaries to draw histograms so that the rectangles will be together. They will be joined together, or your cumulative frequency curve. And in theory, 40 to 44 means you have values from 39.5 to 44.5. The same thing for 45 to 49, you have values from 44.5 to 49.5, and so on. The simple thing you have to do there is subtract 0.5 from your lower class limits and add 0.5 to your upper class limit. Look at it. Subtract 0.5 from 40 to have 39.5. 0.5 from 45 to have 44.5. The same thing here, 49.5. 0.5 from this, 54.5. Add 0.5 to this, 44.5. Add 0.5 to this, 49.5. Add 0.5 to this, add 0.5. So you subtract 0.5 from your lower class limits, add 0.5 to your upper class limits, and what you have what we call the class boundaries. You discover the end here is the beginning of the next one. The end is the beginning. The end is the beginning. In this case, you don't see that. 44 to 45. 49 to that, we call this class that. But for class boundaries, they will be the same. Now, when you take each class, like in this class here, the first class boundary, 39 you have, 39.5 you have here, is called the lower class boundary, while the 44.5 is called the upper class boundary. Another thing you need to know is the class width. The class width is the difference between the upper class boundary and the lower class boundary. Don't use your class intervals. Use your class boundaries. And if you take the first class, you say 44.5 minus 39.5, which will be 5. Similarly, for this class, you say 49.5 minus 44.5 to also be 5, and so on. The class width will be the same throughout. Now, having known this, let's make a table in summary containing those vital information. My table will contain my class intervals, class max, class boundaries, frequency. There won't be class limits because you know them to be these end values. No need to put them. Now, for our class intervals, we said this for the same distribution. Now, the mid values, we've already generated them. The mid value of this is 42, for this 47, for this 52, for this 57. Now, for our class boundaries, we discussed that before. You have 39.5 to 44.5 for this class. For this class, you have 44.5 to 49.5, and so on. Now, for your frequency, to generate your frequency, you go to your distribution. For 40 to 44, you look for 40, 41, 42, 43, 44. So come here, row by row, 40 to 44. 1, 2, 3, 4, and 5. That's why I'm writing 5 here. For 45 to 49, you look for 45, 46, 47, 48, 49. From your distribution, 45 to 49, 45, 46, 47, 48, 49. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's why you see me writing 9 here. For 50 to 54, you look for 50, 51, 52, 53, 54. Row by row, 1, 2, 3, 4, 5. This is 58, don't count it. For 50 to 54. 6, 7, 8, 9, 10. That's why you are seeing 10 here. And for 55 to 59, the last class, you look for 55, 56, 57, 58, 59. Row by row, 1, 55, 56, 57, 58, 59. 2, 3, 4, 5. I have to count again. 1 for 58. 2, 3, 4, 5, 6. I can see 6 of them. Then make sure you add everything. 5 plus 9 is 14, plus 10, 24, plus 6, 30. And we have our distribution here to be 30. 1, 2, 3, 4, 5, 7, 9, 10. 1, 2, 3. That's 10 times this. That's 40. And with this is a table, frequency table for a group data. That's what I want us to learn today. How to make frequency table for group data. We can include tally here. Tally should come before frequency. It's the same. 5 strokes, 9, 5, and 4, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 1. This is a frequency table for a group data containing some statistical distribution, some statistical parameters such as class intervals, where you have your distribution grouped into classes. Your class limits, I told you, are the endpoints of your class intervals. The class marks, which are the center values for your class intervals. The class boundaries, you extend by subtracting 0.5 from your lower class limits and adding 0.5 to your upper class limits. Then to get your frequency, if I say 40 to 44, you'll be looking for 41, 40, 41, 42, 43 to 44. And with this, you will form your frequency table for the group data. From there, you can now proceed to do other things, but we'll stop here today.